This lesson is about sketching planes. So at the end of this lesson, you should be able to sketch planes, given by the equation ax plus by plus cz plus d equal to 0. In general, talking of the graph of a function in three-dimensional geometry, the graph would be a surface. And the simplest of this is what we call the plane. And a plane is described by the equation ax plus by plus cz plus d equal to 0, where a, b, c, and d are arbitrary constants, not all equal to 0. So we can have different forms of this equation depending on whether we have three of these arbitrary constants equal to 0, or any two equal to 0, or any one equal to 0. So here are variations of the equations, and please take note of how the planes are oriented in space for a particular equation. Okay, let us look at now some illustration as to how the plane would be oriented in space given a particular equation. So the case of having x equal to a constant, as mentioned in the previous slide, the plane would be parallel to the yz coordinate plane. So here is the yz coordinate plane. To draw the plane given by the equation x equal to 3, what we do is we locate x equal to 3. So that will be counting 3 units in the positive x direction, and passing through the point 3, 0, 0, we draw a plane that is parallel to the yz plane. So here is the plane of x equal to 3. If we are given the equation y equal to 3, then we expect the plane to be parallel to the xz plane. So to draw this, what you do would be again to locate or to count 3 units in the positive y direction, and locating this point, and through this point you pass a plane that is parallel to the xz plane. So please take note that a plane described by a particular equation, such as in this case x equal to 3, would be observed parallel to, in this case, the plane of the missing variables. Okay, so that if we take a look at how the plane defined by z equal to 3 is oriented in space, then we expect this plane to be parallel to the xy plane. So again, from the origin, you count 3 units in the positive z direction, locating this point, and then pass through this point a plane that is parallel to the xy plane. Now for our fourth example, we have the equation here given by 2x plus 3y equal to 12. The missing variable is the z variable. So we expect this plane to be parallel to the z-axis, not anymore a coordinate plane, but rather just to a coordinate axis. So how do we sketch this curve or this surface? What we do is we first sketch this in the xy plane, and in the xy plane this will just give us a line with intercepts of 6, 0, 0 and 0, 4, 0. So when y is 0, x is 6, when x is 0, y is 4. So we locate these points of 6, 0, 0 and 0, 4, 0, and then what we do is we connect these points with a line resulting to this one here, and then what you do now is let this line translate parallel to the z-axis. So what you do is you move up and down this line. So as you move up this line, it will be passing through some space. Okay, and collectively that will be the plane given by 2x plus 3y is equal to 12. Okay, so for the graph of 2x plus 3z equal to 12, again, there's a missing variable here, which is a y variable, so we expect the plane to be parallel to the y-axis. So what you do again is to draw this line on the xz plane. So you locate the intercepts. When z is 0, x is 6. When x is 0, z is 4. So we locate these points, 6, 0, 0 and 0, 0, 4. We connect these 2 points with a line, and then what we do is we translate or move this line parallel to the y-axis, resulting now to this plane here. Okay, so as expected, for 2y plus 3z equal to 12, you first draw the line that is lying on the yz plane. So that will be this line here connecting the points 0, 6, 0 and 0, 0, 4, which are the intercepts. And then you let this line run parallel to the x-axis, so that you are able to generate this line or this plane. Now, when you are given an equation that involves all three variables, so in the case of having 2x plus 3y plus 4z equal to 12, then how do we sketch the plane? Okay, so if you notice in the previous slides, what we did was to plot the intercepts. So you can start with that. Plotting or determining the x, y, and z intercepts. So for the x-intercept, that will be point where y and z are 0. So if you will be setting y and z equal to 0, you'll be able to solve for x. Out of 2x is equal to 12, or x is 6. So we're able to locate the x-intercept, and this is the point 6, 0, 0. Now, locating the y-intercept is done by setting x and z equal to 0. So, with that, we would just have 3y is equal to 12 and y is equal to 4. So, with this, we are able to locate the y-intercept at the point 0, 4, 0. And then for the z-intercept, we set x and y equal to 0, and that would return a z value of 4. So we have this point. This is the y-intercept 0, 0, 3. So what we do is we connect any two of these intercepts. So we connect the x and the z-intercept, resulting to this line. Now this line, which is on the xz plane, is referred to as the xz trace of the plane. Connecting the z and the y-intercepts would give us the xz trace of the plane, and the line that results to connecting the x-intercept with the y-intercept would give us the xy trace. Now the trace of a surface is just the intersection of the surface with any of the coordinate planes. So with these examples, we hope that given a linear equation of the form ax plus by plus zz plus d equal to 0, where a, b, c, and d are arbitrary constants not all equal to 0, that you would be able to sketch the plane associated with the equation. Okay, so I will see you in the next lesson.